So in today's lesson, we're going to look at what reactions are and what their indications or how we know that a reaction is happening, rather than just say boiling water, which is not a reaction, it's just a physical change. So what can we notice in a reaction that tells us that a reaction is actually happening? So that's what today's lesson will be focusing on. So indicators. Many reactions release or absorb forms of energy when they occur. When a reaction happens, they either emit or receive energy in some form. So here, if we look, a reaction can be sort of identified by the fact that the color is changing, because color changes imply that the electrons are then reconfigured such that they can absorb and emit different forms of energy in terms of different colors. So there's three major forms of energy that we're interested in. That's light, heat, and electricity. So light is pretty obvious in, say, a combustion reaction. We can see lots of light, fires and things like that. Heat, same thing. Heat comes out of a combustion reaction as well. Not electricity though. Electricity doesn't happen. In some reactions, electrons can actually be forced around a circuit, and that can actually generate electricity. Those are the three major forms of energy that we're interested in. So light. So here we have an old incandescent light bulb from the Edison days. Very, very inefficient. Sort of an archetype of lighting. It emits light, obviously. So light is an electromagnetic energy. For those who've studied physics, electromagnetism shouldn't be too much of a stretch for you. But essentially all it is electric fields and magnetic fields interacting with one another to produce light. Many reactions, particularly combustion reactions, release light as a form of energy. Combustion reactions aren't the only ones. A glow stick, for instance, when you mix two chemicals, they'll produce light. Certain insects and other organisms have what we call bioluminescence. So they'll actually mix chemicals in their body to produce light. The anglerfish, for instance, has that little light bulb thing in front to lure other fish closer so it can consume them. So it produces that light through a chemical reaction. That's one way that energy can be expended or can be released into the environment through chemical reactions. One of the most famous, probably, light absorbing reaction is photosynthesis, where carbon dioxide and water are converted to glucose and oxygen. So that's a very famous, everyone should know about photosynthesis by now. And it's the biggest one, the most prevalent one in our society as well. So heat. Heat is generated in many reactions as well. Combustion, once again, produces lots of heat. And it is related to the energy of the particles, and thus is a form of energy transfer in chemical mechanisms. The temperature is related to the amount of energy that the particles have, and heat transfer helps to change that temperature through different systems. That's just what it is. Combustion reactions all release a large amount of heat, because that's what combustion does. And we can actually use that heat for many useful things, like spinning a turbine, or making steam to spin a turbine to make energy, like a coal-fired power plant. Or we can use it to sort of expand a gas and push down on a piston, which makes an engine move, which makes cars move. So we use heat for a lot of very useful things other than just keeping warm. So heat can be used for lots of things. And the study of heat and its interactions is what we call thermodynamics. So other times, some reactions like decomposition take in heat to split a chemical into its constituent compounds. So if I was to heat up a carbonate, like calcium carbonate, I could split it up into carbon dioxide and calcium oxide just by applying heat. Okay, so that's when heat is taken up by the system to produce a chemical change. Lastly, there's electricity. So electricity is the energy related to the flow of charge. Okay, so when we have charges flowing, there's an energy associated with that, and that's what we call electricity. And typically that flow of charge is through the flow of electrons, but sometimes it can be the flow of other charges as well, positive ions or negative ions as well. Don't be too concerned about what the charges are. Just be aware that electricity is about the flow of charge. And actually some reactions can generate electricity. They can actually produce this flow of electrons or charges. And batteries are one example of this. Batteries actually consume chemicals to produce electricity. And that's probably the only, other than maybe fuel cells. Okay, fuel cells may be the other example of this, but batteries are the most common example where chemicals are consumed and thus electricity is produced. Now, once those chemicals run out, we say the battery is flat, so it no longer produces electricity. Now, the opposite is if we were to use electricity to make a chemical reaction happen, and we call that electrolysis. So electrolysis reactions absorb chemical or electrical energy to change chemicals to other form. The battery changed chemicals from one form to another to produce electricity, whereas electrolysis takes in electricity to change chemicals from one form to another. Okay, so there's just the reverse processes of the two. Okay. So that concludes today's lesson on reactions and indicators. So we've looked at how we know a reaction is happening and how we know that through the different forms of energy that are emitted, produced, or absorbed. So we'll move on to the question segment now, and hopefully we can learn some more about these forms of energy and chemical reactions.